Okay, here we go. So we're going to use the quadratic formula to rearrange equations, and basically what it is like is making a variable the subject of an equation. So here's the problem. If 7x squared equals 6ax plus a squared, solve for x in terms of a. So what I want to do is I want to get x by itself. Okay? I want to rearrange this equation and get x by itself, which I cannot do, I can't do without the quadratic formula. Okay? So first up, this is a difficult problem, but what I want to do with the quadratic is I want to make sure that it's set up in this form: equal to 0, squared term, then x term, then constant term, all on the left side, all equal to 0. So by the looks of it, if I want to solve for x, that's going to be my first term, 7x squared, and I'm going to take these two terms and shift them over to here, setting this equal to 0, and when I do that, I'll change their sign, so that becomes minus 6ax, and that positive a squared becomes negative a squared. Alright, so right now that doesn't look like it's in this form at all, but it is in terms of x. I've got my x squared term, my x term, and my constant term, even though that doesn't look like a constant term, but in terms of x it is, because there is no x. Okay, so that right there is kind of a tricky idea. My next bit, like I was solving for the quadratic, is I label a, b, and c. A is the coefficient of the x squared term. A is 7. B is, I guess, the coefficient of the x term here, which is negative 6a, and that looks rather different. And c is my term that has no x, or negative a squared. Okay, now that step right there could throw some people for a loop, but we can handle it. All right, so now, next up, I'm just going to take these and substitute them into the quadratic formula as if they were just regular numbers. So I've got x equals the opposite of b. The opposite of b is 6a, plus or minus square root of b squared minus 4 times a times c. Make that a little bit longer there. All over 2 times a. Okay? So with the quadratic, I just substituted all of these values into the formula. Okay? Now I've got a simplifying under the square root symbol here. Nothing's going on with the 6a, plus or minus. Negative 6a squared is 36a squared. All of this, negative 4 times 7 times negative a squared, comes out to positive, 7 times 4 is 28, positive 28a squared. All over 2 times 7 is 14. Take it to the next step. X equals that 6a is just kind of floating along. I can collect like terms here and get 36 plus 28 should give me 64, I think. 64a squared all over 14. Now, this is coming together. In this case, right here, the square root of, that's a perfect square right there. That guy, that's 64a squared has an actual square root to it. 6a plus or minus, because the square root of 64 is 8, and the square root of a squared is a. Still over 14. Now I made up this problem, so this answer kind of comes out clean, which means like this simplify. The fact that that came out to 64a squared will not always happen. That may or may not be the case all the time. All right, so of course it's a quadratic, so a lot of times I get two solutions. One of my solutions will be 6a plus 8a over 14, and my other solution will be 6a minus 8a over 14. And of course the first solution, the one on the left, gives me 14a over 14. Those cancel out, and I'm left with x equal a. Well, that's interesting. Okay, so they're the same number, the same value. And on my other solution, 6a minus 8a gives me negative 2a over 14. And I can simplify that coefficient and get negative 1/7a. My a looks like a 9, but it's not. Okay, so I mean, those are my solutions in terms of a. What value of x is, I don't know. I know that these guys will be the same value, and x will also be negative 1/7 of whatever a is as well. So my two solutions there. Now, without the quadratic formula, we can't do anything there. And so we'll do some more practice in a little bit. Okay.